Mr. Pushpam Kumar. He is National Manager Refurbishment, Sika India Private Limited. He is academically an engineer with Masters in International Marketing from Indian Institute of Foreign Trade. He has been with Sika India since 2011 at various positions to support refurbishment products for concrete repair, grouting and fixing, structural strengthening with CFRP and protective coatings. Prior to Sika, he has been associated with Austrian company and has contributed in structural retrofitting. With his 22 years of overall experience, he has worked for more than 17 years in concrete repair and rehabilitation. So today he will be speaking with us about the state-of-the-art solutions for effectively using grouts and sealants for precast joints to ensure leakage-free precast structures.
Today, I am supported with my colleague Ritesh, so we would be talking about joints and connections. Let me start the presentation here. When we talk about precast construction, usually it comes to mind that while building a structure. But if you see, precast has wide application areas, like right from building to bridges to wind towers to various kind of railway sleepers we have recently just discussed, tunnel lining and tanks. There are many of the applications. And Sika has complete solution for each and every application areas for precast, right from the construction of precast members to the repair, to the surface appearance, anchorage, grouting, all kind of applications Sika has got. I would not go in all those details as the agenda is set for joints and connections. So we would stick to the joints and connections for today's discussion. I would be talking about connection. My colleague Ritesh would be talking about joints. You can see some photographs. Of course, these are not the good photographs. You can see massive failure in precast construction. And unfortunately, this is something which is happening because of the connection failure. So, thankfully we have some code now, like Mr. Amit was here, and I really thank that we have the revision in the code where we have detail about the precast construction. And of course, there are various international codes available. I will talk about the seismic guidelines, this ACI 550, which talks about the emulative detailing. In short, I would just go by very simple way. Emulative detailing has clear expectation that the precast member should act as just monolithic, as cast steel structure. So the expectation is very simple. And there are various connection systems. Like you can see, there are bolting method, there are welding method, there are grouting method. But now, considering the ease of application, grouting method has been widely accepted for the precast construction. So here you can see the joints. The joints are deliberately created, and this is for separation between the various members. And the joints has to be sealed, and there are complete technical solution from Sika for sealing those joints. I will talk about the connection part. Connection part, you can see here, the precast connections are designed to transmit forces between the structural element and ensure safety and durability of a precast building. This carry the predefined loads in the different building structures and resist the fire and the water. So this connections are designed for transmitting load from one member to other member. Means it has very important role to play. In the previous session, Dextra team has explained about the various coupler system. Grout is one very important part in this whole system. So let me come to the grouting part. As you can see, there are various precast connections like hollow core slab, wall to wall, beams, and the corbel connections. Various foundation to column connections, column to column connections, column to beam connection, beam to slab connection, a staircase connection. These are some of the photographs where these groutings are required to connect the joints. So in one of the sessions, I heard that someone was asking that what is the ingredient of grout. So we have captured here, grout is basically, you can see this has filler, which is basically the sand or fine aggregates. It has binder, cement, the fine additive, and water. And this is designed in such a way that it has to act as a load transfer material. Like in short, if you see what is grout, it is basically a load transfer material from one member to another member. There are a standard specification given by ASTM-C 1107, and ASTM-C 1107 talks about non-shrink term, and they have further elaborated non-shrink term. There are three grades. One is expansion before hardening, one is expansion after hardening, and the third one is in both the conditions. So what does it mean? Cementitious grouts are made up of cement. So the inherent property of cement is during hardening process, this will shrink for sure. Nobody can stop it. So whatever shrinkage is happening, that has to be compensated, and that compensation is done by expansion method. And the grout manufacturer has to take care of those application areas, like those parameter, how this expansion would be happening in both the stages, in elastic stage as well as in the plastic stage. So whatever shrinkage is happening, either in elastic stage or in plastic stage, that is taken care by, compensated by this grout through the expansion process. So in addition to this grout definition, ASTM-C 1107 also gives the performance requirement, how and what should be the performance requirement, the various test method, and the reporting method, that how the grout should be reported. Unfortunately, I have not seen, like whenever I see the specification, especially in precast or for many of the application area, I do not see the detailed specification. And from this forum, I would like to request the designers, because you can understand that the designer's design is at stake if the connection fails. And connection is totally dependent on the type of grout and the performance of grout. So they must give clear specification for the type of grout, the performance requirement. You can see some of the properties of the grout, like it should be dual shrinkage compensated, as I explained. This should expand in elastic stage as well as in the plastic stage. The high compressive strength is another parameter. High flowability, because in case if the grout is not flowable, it would not be able to travel through the precast members. Creep resistance, because it has to sustain the load for a longer duration. Then dimensional stability, there should not be any physical damage once the grouting is done. Resistance to dynamic and static loading, chemical resistance, and the anti-corrosive nature of grout. So these are some of the important properties of any of the grout material. And for purpose of grout, like for ease of understanding, we have divided into two parts. One is the ability to transfer load, and the second one is the complete filling of void. These are the two expectations from any of the grout material. So ability to transfer load, the effective bearing area, EBA, should be high for any of the grout material. I would explain the EBA part. Then there should not be any segregation or bleeding in the grout material. For complete filling of void, expansion and compensation or low shrinkage is very important parameter, and the flow characteristic is another important parameter. So in case if everything falls in line, then only we can say these are the clear performance requirement of the grout material. For mixing, I have explained in the video, but especially for grouts, these are especially formulated with high additive, and the mixing plays very important role. In case if the grout is not mixed properly, the reaction, hydration reaction will not happen, and the properties of grout would not be achieved. So the minimum mixing time for any of the grout through the stirrer should be minimum 3 minutes, and it should be at RPM of 400 to 500. In case if it is not mixed with the proper RPM, if the RPM is too low or if the RPM is too high, then also the performance of grout would not be achieved. And the next very important aspect is the pouring technique. Whenever we are pouring grout, there should be sufficient pressure head so that the grout is flowing and it is filling all the cavities. Another important aspect, the water powder ratio. As you can see this graph, that when this compressive strength is inversely proportional to the water powder ratio. More water, lesser the strength. And every grout manufacturer has recommended their water powder ratio. So restrict to the defined water powder ratio, because at site none of us is there. The labor who is working does not understand the importance of water powder ratio. So there should be proper guidelines, checkpoints, that they are not mixing extra water. Otherwise, the compressive strength of the grout material would be less. Second important aspect is the temperature, how this influences the grout. Like you can see here, the three different situations. One is at 10 degree, the compressive strength again at 10 degree. Second one is 20 degree, and the red one is 30 degree. So you can see, if when the temperature is very low, the strength gain would be happening at a very slow pace. You can see 1 to 3 days strength gain would be very, very slow, but at later part, after 3 days, the strength gain is normal or rather better. Why? Because the initial temperature was less, the water molecule had evaporated at a slow rate after complete hydration of grout, and then the strength gain is complete. The second one is 20 degree, where we can say the initial, even 20 degree or 30 degree, the initial performance is high, like 1 day or 3 day performance is high, but at to later stage, 28 days, the compressive strength is relatively low. So this is a very important aspect, that the temperature part should be taken care when the curing is done for the grouted section. Now, when the manufacturer role is there to provide you the material, but on site, what should be the checkpoint? The QA/QC has a very important role to check each and every parameter. And especially for grout, I can tell you that these are very simple kind of test or simple method how these monitoring can be done at site. These are very, very simple, easy to do kind of testing. Like one is the density test. Second is the segregation and bleeding, the consistency of flow, strength development, adhesive bond, shrinkage expansion, setting time, effective bearing area. These are something every test is possible at site level. So whenever you are using any grout material, please ensure that you have record of each and every parameter. I again repeat, the designer's design is at stake if the connection fails, and the connection has very important role with grout material. You can see this photograph, in case after the grouting, if you see some water. So bleeding is something which at every batch during the regular process, it can be checked. The segregation can be checked by taking out any core. Whenever we are doing any kind of, cube crushing or cube test, we can see how the segregation is there, whether bleeding has happened or not. Second is the flow test. Very easy, very handy test at site. The moment you are mixing grout for pouring, take out a small quantity of grout, put it in this flow testing plate. Just see whether you are getting desired flow. Usually, it should be greater than 250 meter. Like this cup cone has top is 70, bottom is 100, and the height is 50. And when it is filled properly, the moment you lift it, the spread should be minimum 250. But a good performance grout, you would always find that it is more than 280, 290 mm. What it indicates that when the grout is mixed properly and if it has a very good flow characteristic, even if the narrow passage is there, the grout material would be flowing inside all the cavities inside the connections. Then is the compressive strength part. Like we always have, like most of the site has got this test procedure. Either you can use EN 196, wherein you can do the compressive and flexure test both, or we can use ASTMC 1107 for taking the compressive strength result. So this is another important aspect, that can give you a clear indication that when the connection or the precast member, when it has been joined, whether that particular grout, that batch has achieved the result or not. Next is effective bearing area. Most of the time I have seen people are least bothered about EBA. What does EBA mean? As I said, grout is a low transfer material. In case on the right hand side, you can see this photograph. In case if you have the 70% effective bearing area, means the load transfer would be happening only through the 70% contact surface area. And the code says that it should be greater than 85%. So if you are able to achieve EBA of 70 or 80%, means it has not met the performance requirement of the grout. So please make sure that EBA should be checked. The setup is very small. On the left hand side, you can see this photograph. It is a very small setup wherein we put certain head, 250 head. We pull the gate and then we see how the grout is flowing. And there is, on the top, there is an acrylic sheet. After 24 hours, we open this acrylic sheet and we check this, that what is the EB. And these kind of tests can be done at site, or we can invite at our lab for demonstrating these kind of tests. But these are very, very important parameter for testing. Now, the calculation part is very important, because sometimes what happens at project site, they do not understand how much grout should be mixed for, because they know that, okay, I have to grout 5 panels or X number of couplers, but they do not know that how much material is required. So what happens? Either the mix excess of material or less of the material. In both the cases, in case of the less of material, the waiting time is more. The grout material, like partly you have used a grout which has been mixed and it has crossed the pot life, and then again we are mixing. Or in some case, what happens, the excess material is mixed and this has gone for waste. So this is very simple. Weight of powder plus weight of water divided by density. This gives you the yield, and you know from your sleeves or the precast connections that how much of grout material is required, so that we can calculate accordingly that this much of bag or this much of material should be mixed. So with this, I conclude my topic. I would like to request my colleague Ritesh to take over the joint part, wherein the sealants are very, very important.
Hello everyone. So whenever we are discussing about sealing the precast joint with regard to water tightness, we come across following situations. People ask, the design life of precast structure is 50 plus years. What is the life expectancy of a sealant? That is very valid question. Some are skeptical. They plan to seal with mortar. Some who are convinced they want to seal, they need a guide on applying a sealant, whether there is a code. The expectation is to seal to submarine standard to keep all water out. And that's very important. And then we have actually suggestion how to help with the cost to find effective solution. The point is, most of the precast elements, they are manufactured off-site, but the critical job of sealing the precast joint, that is done on-site, and then the quality work takes the backseat. Now, first of all, we need to know what should be the minimum joint width. In the previous session, most of the speakers have elaborated, we need to minimize the joints, or it has to be eliminated, because that is the weakest link through which the water ingress or the leakage happens in the structures. So first we need to calculate what is the actual movement which should be happening across the panel, and that would be calculated by knowing the simple linear thermal expansion formula. So in case if the element is of 10 meter length, and considering it will be exposed to temperature ranging from -5 to 45, that the temperature delta is 50, and considering the coefficient of thermal expansion, for 10 meter length, there would be a change of dimension of 6 mm. So if you have two precast element, so at least as per this assumption, there should be 12 mm gap. But is it enough? For example, instead of 12, you have 13 mm. Okay, so is it possible to have a material which would compress to 1 mm and then expand to 12 mm or 13 mm? That material would be subjected to a stress of 1200%. Only the bubble gum kind of thing material could address that. But again, that would be only for one time. Then the most important thing any consultant, any the client or contractor need to know in selecting a right sealant is MAF. Now this MAF, that is movement accommodation factor or movement capability of the sealant, is declared by the manufacturer. Okay. So that gives an idea, MAF gives an idea what is the maximum compression or maximum expansion that sealant can accommodate without having a failure. So this MF is calculated in a lab where the sealant is subjected to a temperature ranging from -20 to +70 with different compression and expansion. There are 10 cycles. That test runs for 2 months. And this test doesn't happen in any labs in India. You require a nitrogen chamber to have that lower temperatures. And only when there is no cohesive and adhesive failure, the manufacturer declares that the sealant has that capability. So what is the implication? So in case the designer or the consultant has designed the joint considering the sealant MAF of plus minus 25, and at the site you have a sealant having MAF of plus minus 12.5, you have a cohesive and adhesive failure. So from the actual moment, how does one calculate the theoretical width? First of all, calculate the movement due to thermal expansion across the two panels. And after having the data of MF, taking into account the construction allowance, you arrive at the theoretical width across the panel. Now, what are the qualitative considerations that has to be given? It is preferred to have a recess, because in case if the sealant is flushed, then it will lead to faster deterioration due to high UV exposure. Recessed seal gives a protection and also aesthetically it may look good. Again, it is not necessary if the sealant is too deep, it can lead to a stiffer material and there could be an adhesion failure. So there should be a right depth of a sealant and right width of sealant to be used at the site. So if you had tooled the sealant very shallow, then definitely there would be cohesive failure. Now, this is the typical geometry. What should be the right dimension of the sealant? In case if the width is less than the depth of the sealant, you see at the extreme fiber, there would be more strain, 94%. If the shape factor is width and depth is equal, the strain at the extreme fiber of sealant is 62%. And in case the depth is half of the width, the strain is very less. So this is an ideal situation. Now, how the precast joints are usually sealed in India is face sealed one stage joint. That external sealant is providing a barrier against air and water penetration. Plus point, it can be done at lowest cost. It can be readily inspected. Best for low-rise construction. Panel edges have a simple profile, and the cost for a dimension of 20 by 10, it would be less than 80-90 rupees running meter material cost. Cons, you require external scaffolding and sealant is exposed to UV light, and in case if there is a failure, then it will lead to a leakage. You don't have a redundancy built in this. Other type is you have a sealant applied both internally and externally. So airtight inner seal and water barrier outer seal. Then this is preferred for the high-rise structure where you have a slot between the two precast panels and you have a baffle which act as a barrier against the water ingress. But for this, you require a very skilled applicator for installation. Third, one can go for a compression sill where you have a preformed, pre-compressed polyethylene foam which is inserted into joint. So this is just like a gasket, simple and quick to install and very economical. But this is only suitable for low rise, not for high rise. Again, from the design point of view, these are the few pitfalls which one can avoid. One need to avoid T-junction wherever possible because this would lead to a stress at the junctions. That should avoid vertical joints between two openings, which you see in the circle part. Now coming to the selecting right chemistry for the joint, because anything sealant as just a gap filler, that should not be the case. These are chemistries are available from latex, acrylic, butyl, polysulfide, hybrid, and this chemistry is mapped against different application. If you see the yellow highlighted row for the precast, the silicon and PU are rated 4, that means excellent. Why it is so? We have given a differentiation, we have compared different chemistry. You can go with a mortar, but it will be very rigid. Acrylic has a limited movement capability. Silicon can have a capability from plus minus 25 to even 100. Same is the case of modified silicon. And PU, again, it has best in class MAF. Elongation is more in PU. Adhesion to concrete, that is most important parameter while selecting a sealant for sealing precast, that is you have modified mortar and then PU. Then paintable. Except for silicon, most of the sealant are paintable. Then life expectancy, this is the indicative I've given. This is as per the site lab conditions. Now, what is the right time for installing, filling the joints? So this I've taken from the ASTM code. For example, if you are filling the sealant in winter, the temperature is minus 20 and the width is W. When the temperature rises to 13 degrees Celsius, the gap closes to 2/3 of the original width. And when the temperature reaches 54 degrees Celsius, the gap reduces to 1/3. So the sealant is being compressed by 66%, and there is high chances of failure. Another scenario, if the sealant is installed at high temperature, the gap would be minimum. Let us assume that is W. And when the temperature drops, the gap becomes 2W. And further, when it goes below 0 or minus, the gap is 3W. So sealant must extend by 200% in service. So this should be avoided. Again, if you're installing in lower temperature, the amount of sealant would be on higher side, Okay, so it should be just installed above the mean temperature. Only main thing one need to consider over here is while installing the backer rod, you should be using a proper roller instead of using a sharp object, because this backer rod, that is closed cell backer rod, when it is punctured, it would result in outgassing. The outgassing happens for 4 to 6 hours, and this would then get trapped in the sealant. This will be leading to bubble formation. And again, while applying a primer, now primer is again a solvent base, you should wait for half an hour or maybe as specified by the manufacturer for the solvent to evaporate and then use a sealant. Now, most important part, how do we test the water tightness? Last year, we had this code, and in this code, they have specified there are two methods to testing water tightness. Now, this is the lab method, and this method is very similar to ASTM 1105, where the water is sprayed on the sealant, and then you have a blower, okay, that creates a differential pressure. So they have given few guidelines, what should be the water flow rate and for what duration. This is not possible at the site level, but one can definitely go for second test method. In the second test method, they have specified that continuous jet of water shall be sprayed on the joint corresponding to 600 liters or maybe 10 liters per minute, quite possible. Even by having 0.5 HP pump or 1 horsepower pump, it can be achieved. With the nozzle velocity of 2 meters per second and a cone catter of approximately 60 degree. And it should be held at a distance of 1.2 meter from the wall surface. So this is the one important test which can be done at the site to check the water tightness. Thank you.
Any questions? They will answer.
This is regarding the grout, what you have talked about. Now, when it is called, we are saying as a non-shrinking grout. So which standard you need to apply, because it depends on whether ASTM, EN or FIB bulletin, whatever it is. But is there any Indian standard is involving? And when you talked about the grout, so both the methods, whether it is EN 1961 or ASTM, but is there any equivalent Indian standard, or we have to test it in the cement mortar cube? Because EN 196, what they do it on the cement testing or cement mortar prismatic mode, the test is being carried out. But in the Indian standard, do we have a method? And if we have method, what should be the size of the mold?
Okay. So to be honest, I am just missing the number, but yes, there is one Indian standard, but of course it does not cover the complete parameter. Like few of the parameter has been given, but as you asked that what is the size of the cube? So in an Indian standard, the size is defined at 70.7. So 70 cube is used for testing the grout.
Same cement mortar cube?
Exactly, sir.
But the filling, whether it has to be like cement, we fill it in 3 layers with tamping. Here, there must be
Same
some
method,
process.
sir.
Same method.
Same method. The first layer, then tamping is done. For second layer, tamping is done. Then third layer, and then we finish the cube filling.
Especially the shrinkage test is carried out at what age?
So shrinkage, there are different parameters. Like for IS 1119 is there where the shrinkage is done. So shrinkage is tested in curing period also up to 28 days, and for long term for 28 days and onward also is test. So there are various test method for doing the shrinkage test, but shrinkage is very, very important parameter for this.
But at any early age, before 28 days, in few hours, or what you can say after?
Not
say,
in few hours. In few hours, shrinkage can be checked. Like in case if the grout material has any shrinkage behavior, which at all is not recommended for grout, that can be visible in 24 hours. The moment you see the cube, you will find that the shrinkage has happened.
Okay, but in any relevant standards like FIB Bulletin 20, does it specify for that?
Yes, FIP 20 is there, which talks about this parameter.